Hey everybody! In this video, we're going to be learning about the product rule for derivatives. The big question is, how do you find the derivative of a product of functions? For example, if y equals f of x times g of x, is the derivative f prime of x times g prime of x? No! Unfortunately, this is not correct. If y equals f of x times g of x, then the derivative y prime equals f of x times g prime of x plus g of x times f prime of x. You could think of this as the left function times the derivative of the right function plus the right function times the derivative of the left function. And a quick way to remember this is left d right plus right d left. Say this phrase to yourself a few times. Left d right plus right d left. While we're not going to prove the product rule in this video, I am going to show a problem that illustrates how this works. And then we'll solve a few example problems. Suppose y equals x to the 24th power. Now we know from the power rule that y prime equals 24x to the 23rd. But let's suppose we split y into two functions. F of x equals x to the 15th and g of x equals x to the 9th. Then we can see that y equals the product of these two functions. X to the 15th times x to the 9th equals x to the 24th power. If we take the derivative of f of x and g of x and multiply those derivatives together, we can see that this would not equal 24x to the 23rd, which is the derivative of our original y function. The derivative of f is 15x to the 14th, and the derivative of g is 9x to the 8th. Multiplied together, those do not equal 24x to the 23rd. This is super wrong. But if we apply the product rule, left d right plus right d left, we'll get the correct answer. Let's take a look. Y prime would equal x to the 15th times 9x to the 8th. That's f of x times g prime of x. Then we're going to add x to the 9th times 15x to the 14th. That's g of x times f prime of x. The sum of these is 24x to the 23rd, which is the derivative of our original y function. So this is an example that shows the product rule works. Let's try an example. Suppose y equals x to the 3rd times e to the 2x. Let's find the derivative. Y prime would equal the left function times the derivative of the right function plus the right function times the derivative of the left function. This gives us x cubed plus e to the 2x times 2 because of the chain rule, plus e to the 2x times 3x squared. We could stop here, or we could simplify by factoring out an x squared e to the 2x. This would leave us with y prime equals x squared e to the 2x times the quantity of 2x plus 3. Let's look at another example. Suppose f of x equals ln x times sine x. Again, this is a product of functions, so we're going to apply the product rule. Left d right plus right d left. So applying this rule gives us ln x times cosine x, because cosine is the derivative of sine, plus sine x times 1 over x, because 1 over x is the derivative of ln x. And that's it. That's the derivative. Let's look at one last example here. Suppose we want to find the second derivative of y equals e to the x squared. Well, in order to find the second derivative, we need the first derivative. Y prime would equal 2x times e to the x squared by the chain rule. But now, when we want the second derivative, do you see that we need to use the product rule? Because we have a product of two functions. So let's apply the product rule. Left d right plus right d left. The left function is 2x. The right function is e to the x squared. So our derivative is 2x times e to the x squared times 2x because of the chain rule, plus e to the x squared times 2. We can clean this up a little bit by factoring out 2e to the x squared and then multiplying by the quantity of 2x squared plus 1. That's the second derivative of y. So in summary, when you need to find the derivative of a function that's a product, you need to use the product rule. Left d right plus right d left. That's the left function times the derivative of the right function plus the right function times the derivative of the left function. Make sure that you memorize this so that you can quickly find the derivatives of products. And that's how you rock calculus!